So in this video, I will try to discuss tutorial question. So I'm going to start with the objective one first. Question number one, for an object to move in uniform circular motion, it must move with constant speed. Okay, so like I told you before, for uniform circular motion, the speed is constant, the velocity is changing because the change in direction. So B and C is incorrect lah. And then because V changing, momentum also change. Okay, so question number two, which of the following unit conversion is correct? One revolution is actually equals to one complete cycle, right? So that one would be 2 pi radian. So A is wrong. Pi radian is 360 degree. That one is incorrect as well. Should be 2 pi radian. C, incorrect. The correct one would be D, donkey. One revolution is one complete rotation. A car moves around a circular path of a constant radius at a constant speed. Circular path, constant radius, constant speed. Which of the following statement is true? Basically, this one is circular motion lah. The car velocity is constant. That one is incorrect. The speed is constant. Changes in direction, so velocity changes. Car acceleration is 0. That one is incorrect as well because velocity changes. You should have acceleration, centripetal acceleration towards center. Velocity directed to the center. This one is incorrect. That one should be the acceleration. Car acceleration is directed. Okay, that one is correct. So the answer is D. Question number 4. A ball attached to a string is moving anti-clockwise in a vertical circle. Okay, so vertical circle like that. Anti-clockwise, maybe in that direction. If the string is cut exactly at the point where the ball is at the top, so this is the string and the ball. What direction will the ball move initially? So at this particular point, the velocity will be directed to the left. Velocity should be tangential to the circle. So the answer is A. Centripetal force has the same direction as centripetal acceleration, which is change in velocity. Okay, for question 6 is about definition, so I'm going to skip that one. Question 7, it says that a car is traveling at 100 km per hour. The radius of the car wheel is 30 cm. How many revolutions per minute is the car wheel make? So they are talking about the car wheel. Traveling at 100 km per hour, that one is your V, linear velocity. The radius of the car wheel is equals to 30 cm. So R, I changed to SI unit 0.3 meter. How many revolution per minute is the wheel make? So when it says revolution per minute, this one is RPM. So when the question asks you to find the RPM, basically the question wants you to find the omega, but in RPM lah. So SI unit for omega is radian per second, and you have to convert to RPM. So you have to find the omega first. To find omega, you can use the relation that I told you before. V is equals to R omega, right? So V is equals to R omega. You do have the V, but the V here is not in SI unit, so you have to convert it first. So to convert this one, I strongly suggest you to use cross multiply. So this one is kilometer per hour, so I want to change to meter per second. So if I want to cancel out the kilometer, I have to put in the opposite side. So kilometer is up there, so I have to put kilometer down here, and I want to find the unit M. So 1 kilometer is 1000 meter, and then I want to change hour to second, so I have to cross the hour there. So I put H over here, second over there. So 1 hour is 3600 seconds. So 100 kilometer per hour is actually equals to 27.78 meter per second. Okay, so that one is the V in SI unit. Now you have to substitute back inside the equation V equals to R omega, so that your omega is equals to V over R. V is 27.78 and R is 0.3, so both of these are in SI unit. So the final answer would be in SI unit as well, which is radian per second. So here I got 92.6 radian second. Okay, now I have to convert to RPM. So omega here is equals to 92.6 radian per second. So radian per second. I want to convert R radian per second to RPM. RPM stands for revolution per minute. So I have to convert radian to revolution. One revolution is 2 pi radian, and then I want to convert second to minute. So 1 minute is equals to 60 seconds. So you should get omega equals to 92.6 times 60 divided by 2 pi, which is 884.26. Okay, so this would be in RPM, revolution per minute. So in 1 minute, the tires actually rotate 884.26 times. Okay, so just leave the answer like that. Okay, question number B, calculate the centripetal acceleration at the edge of the wheel. This one is question A. Centripetal acceleration is basically AC. Okay, so then we're going to find AC over here. So direction of AC will always be towards the center there, center of the circular motion. So you can use equation of AC equals to V squared over R. Okay, I use everything in SI unit. So V in SI unit is 27.78 square divided by 0.3. Is it 0.3? Yes, 0.3 meter. So your AC 2572.43. So everything in SI unit for linear acceleration is basically ms minus 2. Okay, so next question is question number 8. If an object of mass 3.5 kg is traveling in circular path with a radius of 3.14 meter at a speed of 3.46 meter per second, what will be the centripetal acceleration AC and centripetal force FC? Okay, I think this one is straightforward. They do give you the radius and the velocity, so you can straight away use the formula of AC. So AC is equals to V squared over R. So if I want to take out the information first, so mass is 3.5 kilogram, radius R is 3.14 meter, and speed V is 3.46 meter per second. So make sure everything is SI unit. Now you can substitute inside here, it becomes 3.46 square. R is 3.14. So if I press my calculator, should get 3.81. Okay. And for question B, they want you to find the centripetal force FC. So FC is equals to MAC. So calculate just now 3.81, multiply with the mass. So FC, because this one is force, the unit will be Newton.